5-1, chapter 5, section 1. We're doing nth roots. We're doing all things radicals. First thing we're doing is we're simplifying radicals, okay? So if you look at this first example, we have the cube root of 125, x to the 6th, y to the 3rd, z to the 15th. You know it's a cube root because the index number is 3. Key vocab there. You'll hear me ask what the index number is. The number in the little v part of the radical is called the index number. Okay. All right, so because it's a cube root, we need 3 of a number to take something out of the radical. Okay, so 125 is a perfect cube root. What's the cube root of 125? 5. Good. All right, now to do the exponents, or the variables. To do the variables, just divide the exponent of the variable by the index number. So for x, what is 6 divided by 3? 2. Y, what is 3 divided by 3? 1. Z, what is 15 divided by 3? 5. And we have simplified the radical, okay? See the 3 stars? When you find an even root of an even power and the result is an odd power, you must use absolute value of the result to ensure the answer is non-negative, okay? So, I'll show you an example of that, but if it's an even root, if the index number is even, and then the variable's exponent is even, and then the answer is a variable with an odd exponent, you have to put absolute value around that variable, because if the index number is even and the exponent's even, that number will always be positive. So you have to symbolize that in the answer with absolute value, because absolute value makes everything positive, okay? So I'm actually going to jump down to an example of that. If you look at number 1, also that's called the even, odd rule. I will reference that as the even, odd rule. It's an even index number, even exponent of the variable, odd exponent of the solution. You can put that if you want, you don't have to. All right, if you look at number 1, what's the square root of 144? 12. All right, now what's our index number on a square root? It's understood, even it's a 2, right? So what's 6 divided by 2? 3. P cubed. So this is an example of the even, odd rule. The index number is even, the index number is a 2. If you look at the P, the exponent's even. So we got even, and then the exponent of the solution is odd, P cubed. So that would mean we would put absolute value around the P cubed. All right. Even, odd. Even, odd. Even, odd. Okay. So it's one of those things where the way I do it is after I simplify, when I look at the problem and I see an even index number, I remind my brain, I'm like, Steven, remember when you get to the end, check for the even, odd rule. That's what I say to myself in my brain. Okay? And then when I get done simplifying, I go check and see if I have it. Okay? All right, now back up to example 1. Simplify square root of 49 z to the 8th. What's the square root of 49? 7. All right, then what's 8 divided by 2? 4. All right, example 2, there's a negative on the outside of the radical. All that means is when you're done simplifying, you will still have that negative multiplied to whatever you simplify it to, okay? Now, you have a binomial inside of the radical. You treat it just like you would a variable. In this case, you would do 6 divided by 3. What's 6 divided by 3? 2. So that would be negative 2a minus 1 to the second power. Go ahead and do numbers 2 and 3. All right, number 2. What is the cube root of negative 343?
7, or negative 7. Negative 7.
Good. Number 3, what's the square root of 4? 2. And then what's 10 divided by 2?
5. So you put it in absolute value.
Nice, Royce. Even, odd rule there.
Good man.
All right, go ahead and do 4, 5, and 6. All right, number 4, what's the fifth root of 243?
3.
3. And then what is 10 divided by 5?
2.
2, p squared. All right, number 3. All right, the variable m, what's 6 divided by 3?
2.
2. What's 9 divided by 3?
3.
Good. And then number 6, what is the cube root of negative 27? Negative 3. Good. And then for p, what is 6 divided by 3? 2. So because that negative on the outside, that becomes a positive 3p squared.
Why don't you put any absolute value mark?
Next part here. We're going to simplify the radicals when they're not perfect squares and there is remainders left inside the radical, okay? So if we look at example 1, negative 6, there's not, well, since the index number is 3, we need 3 of a kind. Its prime factors are 3 and 2. So there's not 3 of a kind, right? So that negative 6 just stays inside the radical. Now, if we look at the variable a has an exponent of 5, the easiest way to do this is how many times does the index number 3 go into 5? 1 time. So you can take out 1a. And what would the remainder be? 2. So a squared would be left inside the radical. Then for b, how many times does 3 go into 7?
2.
Twice. So you can take out b squared. And what's the remainder? B. Example 2. All right, we want to go ahead and break that up into 2 radicals. All right, and you don't have to do this, but it helps to go ahead and simplify, okay? So if I were to simplify the numerator, 8 is actually a perfect cube root. Its prime factors are 2 times 2 times 2. So we can take out a 2. Oh, it's a square root. I'm sorry. Haha. Square root. 2 of a kind to take 1 out. So we can take out a 2. And we have a 2 left inside the radical. Again, square root. Need 2 of a kind to take 1 out. All right. Then for the x cubed, how many times does 2 go into 3? Once. And we have a remainder of 1. We have an x inside the radical. The denominator, if I broke that down into its prime factors, if I just look at 45, what are 2 factors of 45?
9 and 5.
9 and 5, and 9 is a perfect square, so we can take out a 3, and that 5 is left inside the radical. Then for the variable y, how many times does 2 go into 5? 2 times. We have a y left inside the radical, okay? So, again, you don't have to do this first. It definitely helps. Okay, so we've been over this a little bit. You cannot have a radical in your denominator, okay? It's against our math rules. Okay, you can't have a radical in the denominator. It's because we'll get into rational exponents in a little bit. We will 5y is the same thing as 5y to the 1/2 power. Can't have fraction as your exponent in the denominator. Okay, so when it's a square root, it's really easy to get rid of the radical. All you have to do is multiply it by itself. Okay, you want to make it a perfect square. So if you multiply this by the square root of 5y, that gives you 25y squared, which is a perfect square, and you no longer have a radical in the denominator. So if you do it to the bottom, you have to do it to the top. That would give you 2x times the square root of 10xy over 3y squared times the square root of 25y squared. And like I said, square root of 25y squared is 5y, right? That's a perfect square. That's what we wanted, so we get rid of our radical. So if we multiplied 5y times 3y squared, that would give us 15y cubed. Number 1. I need to get the prime factors of 54. What are two factors of 54? And 9 is a perfect square, so we can take out a 3. 3 times 5 is 15. And I got that 6, that lonely 6 left inside the radical. All right, jump down to number 4. Square root of 36 over square root of 125. Okay. What's the square root of 36?
6.
All right. Again, you don't have to. It makes it easier here to go ahead and simplify the square root of 125 because we're dealing with smaller numbers. So prime factors would be
5, 5, 5.
correct. 5, 5, and 5. 25 times 5. 25 is a perfect square, so that would be 5 square root of 5. So this keeps the numbers smaller. If you multiply by the square root of 125, that would work. Okay, that's just a big number. Still get you what you want, but here, now that we simplified, a little bit easier mathematically when we have to simplify. Well, we won't have to simplify much. What do you think we'd multiply by here? Square root of 5. Which that gives me 6 times the square root of 5 over, what do you think the denominator would be?
25.
25. Beautiful. Number 2. All right, fourth root of 32, its prime factors would be 2 times 2 times 2 times 2 times 2.
Oh my goodness.
How many of a kind do we need to take one out?
4.
4 of a kind.
What?
The index number is 4. Fourth root. So we take out a 2. 2's left inside the radical. All right, how many times does 4 go into 9?
Twice.
Twice. What's my remainder?
Of 1.
1. And then how many times does 4 go into 20?
5 times. Exactly.
5 times.
And
Even, odd rule. Anybody get that? Anyone get the even, odd rule?
yeah, I got the even.
Oh, yeah.
value. So whenever you do the absolute value, right? Oh wait, yeah, that did move outside. I left it in the radical.
It's okay. All right, number 3. Square root of 75. 25 and 3. 25's a
Perfect
perfect square. Can take out a 5. The 3's left inside the radical. How many times does 2 go into 4? Twice. Good. How many times does 2 go into 7?
3. Wait. Yeah, 3.
3. And what's my remainder?
3.
1. Good. All right. And then number 5.
Wait, next, what number is
Again, I'm going to go ahead and simplify. How many times in the numerator? How many times is 2 going to 6?
3.
3. No remainder. Then for the b, how many times is 2 going to 3?
Once with a remainder.
Good. Once a remainder of 1. So that's actually even, odd rule there. Okay. With the a cubed. Denominator, I want to simplify that. 49 and 2. 49 is a perfect. Take out the 7. We got a 2 left in the radical. So this is a perfect example why it's easier once you simplify. Because what would we multiply by here? Square root of 2. If you do it to the bottom, you have to do it to the top. So my answer is absolute value of a cubed times b times the square root of 2b over 14. Number 6 is a little different because it's a cube root. We're still going to simplify. The numerator. Hold on. Let's go back. Hold on. All right, so we're still going to simplify the numerator. We got cube root of p to the 5th q cubed over cube root of 40. So if we simplify the numerator, how many times does 3 go into 5? Once. And what's my remainder?
2.
Good. And then how many times does 3 go into 3 with the q's?
1.
Once. Good. So we have pq times the cube root of p squared over, if I simplify the cube root of 40 into its prime factors, we can do 4 and 10, 2 and 2, 2 and 5. So since the index number is 3, since it's a cube root, we need 3 of a kind to take one out. So that would give me 2 times the cube root of 5. Okay? So, like we did earlier with square roots, we multiplied just by itself and it would make it a perfect square. But that works sometimes with cube root, but usually does not work with cube roots. If you multiply the cube root of 5 by the cube root of 5, that would give you the cube root of 25, which is not a perfect cube root, right? So we'd still have a radical. We need to multiply that 5 by a number that would make it a perfect cube root. So, easy way to do that, it's a cube root, 3 of a kind to take one out. 3 5s, be able to take one out. What's 5 times 5 times 5? 125. So we want to make it 125. So what would we multiply by? Cube root of 25. Good. We need to do it to the numerator as well. And so that would give me PQ cube root of 25 p squared over 10. As that would give me the cube root of 125. The cube root of 125 is 5. 5 times 2 would give me 10 there in the denominator. Okay, 5 times 25 is 125. Cube root of 125 is 5. 5 times 2 is 10. Okay, next part here, we're doing operations with radicals. So, adding and subtracting radicals. The index number and the number inside the radical needs to be the same to add and subtract. Same as similar concept as variables and exponents, right? You can do 2x squared plus 3x squared. That'd give you 5x squared, right? But if you had 2x squared plus 3x cubed, you could not add them because they have different exponents, right? Kind of a similar concept. So What we want to do here is we want to simplify the radicals and then see if we can add them together or subtract them. So 3 square root of 2, that doesn't simplify any further. Square root of 50, it's prime factors. We can do 25 and 2, and 25's a perfect square, so we can take out a 5. So I have 3 square root of 2 plus 5 square root of 2 minus. Then 4 times the square root of 8. We can simplify 8 to 4 and 2. 4 is a perfect square, so we can take out a 2. We need to multiply that 2 to the 4. So that'll be minus 8 times the square root of 2. So since all 3 terms are a square root of 2, we can add them together. 3 plus 5 is 8. 8 minus 8 is 0. So that answer is 0. 0 times the square root of 2 would be 0, right? So that would be our answer there. Number 2. Simplify 300. I would do 103 because 100 is a perfect square. So I can take out a 10. Have that 3 left in the radical. Minus square root of 27. 9 and 3. Square root of 9 is 3. I can take out a 3. I got that 3 left inside the radical. And then 75, I would do minus, that'd be 25 and 3. Square root of 25 is 5. 3 left inside the radical. So 10 minus 3 is 7. Minus 5 gives me 2. Square root of 3. Number 3, cube root of 81 times the cube root of 24. You can multiply 81 and 24 together and then simplify, but that's huge numbers, right? That's a big number. I mean, huge numbers. That's a big number. So, again, this is easier to go ahead and simplify and then multiply, okay? So, 81, I would do 27 and 3 because 27 is a perfect cube root. And I can take out a 3. And I've got cube root of 3 left inside the radical times 24. I would do 8 and 3 because 8 is a perfect cube root. Cube root of 8 is 2. So that'll give me 2 times the cube root of 3. Now here, the number inside of the radical is the same. It doesn't have to be the same to multiply. Okay, it does have to have the same index number. Okay, it does have to have the same index number, but the number inside of the radical does not need to be the same. So when we multiply here, this will be 3 times 2 gives us 6, and then 3 times 3 gives us cube root of 9. That does not simplify any further, and that would just be our answer there. So, number 4, we would just distribute. Okay, so we would have cube root of 8 plus distribute cube root of 24. Okay, cube root of 8 plus the cube root of 24. From there, we would simplify. What's the cube root of 8? 2. So that'd be 2 plus cube root of 24. Prime factors, we can do 8 and 3. Like we just did. 8's a perfect cube root. So it gives us 2 times the cube root of that 3 left inside the radical. Doesn't simplify any further. Cannot add them together because they don't have same radical with the same number inside. All right, number 5. That will give me 2 times the square root of 45 plus 2 times the square root of 60. So if I simplify square root of 45, I'll do 9 and 5, so I can take out a 3. So that'll give me 3 times 2, which will be 6 square root of 5 plus...
36 and
Sorry, 3 times 60 is 180. And square root of 180, 36 and 5. Which means you can take out a 6. 5's left inside the radical. So you can add them together and you'll get 12 square root of 5. Okay. Yes.
But if there's a 2 there, wouldn't the 6 multiply to the 2?
Yeah, that should be 12 square root of 5, which would give you 18 square root of 5. All right, number 6. I'm gonna do 6 right here for space purposes. Got 2 plus 3 square root of 7 times 4 plus square root of 7. So first gives me 8 outer, gives me 2 square root of 7 inner, gives me plus 12 square root of 7. Last gives me square root of 49, which is 7. Add them together, and that will give me 15 plus 14 square root of 7. Rusty.
Long weekend.
I made that same exact mistake.
That should give you 21. So that will then give you 29 plus 14 square root of 7. All right, here we go. Number 7. First, that gives you 18 times 3, which that gives you 54. And then outer, that gives you 6 square root of 6. Inner, that gives you negative 12 square root of 6. Last, that gives you negative 4 times 2, which gives you negative 8. Okay. So, they're combined like terms. We'll have 46 and then minus 6 square root of 6.